let's look at number 9 for Unit 5. Unit 5D review. So in this one, so part A is like it's another curve fitting problem where I give you a couple of points on a graph and you have to find the correct equation for it. So let's see here. We've got, let me just write out that y equals a b to the x. And in this case, we're going to plug in the point 0, negative 3. So when x is 0, y is negative 3. So that's a, b, and x is 0. And so b to the 0 is 1. So now we get negative 3 equals a times 1, which is just a. So now we have a. So that was pretty quick. So then to get b, so now our equation y equals ab to the x is really y equals negative 3b to the x. And at this point, we can plug in our other point. So if we plug in 1, negative 6 for x and y, then we know negative 6 equals negative 3 times b to the first. And if I divide both sides by negative 3, we get 2 equals b. So there's a and b. So that's part A. That's part A. Let's see. Part B. Give the domain, range, and asymptote. Okay, so this is now our equation is y equals negative 3 times 2 to the x. So really what we did, I mean, you can get the domain, range, and equation of the asymptote just by looking at the function, but you could also base it on the parent, and the parent has the domain of all real numbers. The range is positives, and the asymptote is y equals 0. And then this thing is a vertical stretch by 3 with a reflection across the x-axis. That's the negative part, that reflection. And so what that does is it takes the y's and multiplies by negative 3. So when you multiply the zeros by negative 3, it's still 0. But when you multiply an inequality by negative 3, it flips the sign. So the domain and range and asymptote for our actual function, for this whole function, the domain is going to be all real numbers still. The range is going to be y is less than 0. And the asymptote is going to be y equals 0. Okay, so that's the answer to B. That's the answer to B. For C, it says state those things for the inverse. So the inverse. Now you don't need the inverse. We're just doing it because in order to get the inverse, you switch x's and y's. So if I switch x's and y's, my original domain, this is for the original function, my original domain, the x's could be all real numbers. So that means instead of x's being all real numbers, now y's can be all real numbers. Well, if y's are all real numbers, that's my new range. Right? Originally, the range was y's are negative. If I switch out x's and y's, now x's have to be negative. So that's my domain. And if I look at my asymptote, y equals 0, I have to switch x's and y's. Now it's x equals 0. So here's that info for the inverse. Okay. Now, let's see. For D, it says actually find the inverse and give the answer in y equals form. So here's the original. It's y equals negative 3 times 2 to the x. So the inverse, I switch x and y. And now the goal is to get that by itself because it says y equals form. So in order to get that by itself, let's first isolate 2 to the y. So we'll divide that negative 3 over. So now we've got x over negative 3 equals 2 to the y. And now we need the exponent. And the way to get the exponent by itself is to convert to logs. So remember, the conversion for logs is if b to the, I'm trying to remember the letters that I used in class. I think it was b to the c equals a. That converts to log base b of a equals c. Ooh, equals c. There. So let's see. 2 is my base. So this is going to turn into log base 2. A is the negative x over 3, or x over negative 3, same thing. And then c is y. So it turns into this. That's the conversion. And now y is isolated, and it turns out that this guy is the inverse of this guy. Which, well, never mind. I'm going to stop there.